Have you ever like stumbled upon something super niche and you're like, what is this? And then all of a sudden it's like, damn,
Yeah.
it's in all this new tech. It's like the secret ingredient. You
Yeah.
know what I mean?
Absolutely.
That's how I felt about Iridium.
Yeah.
Because like, Iridium, i- it's not something that, the average person even knows exists. I mean,
Right.
like I'd never seen it, never held it, never thought about it. But it turns out that it is absolutely crucial to so much technology that we use every day, from, the screens on our smartphones to even the future of green energy.
It really is sort of a hidden champion of modern technology. And yeah, that's what makes it so fascinating. So today we're going to take a deep dive into the world of Iridium. We're going to look at its current market, and we're going to look at, how its price has fluctuated so much. And we're going to even look at the truly out there idea of potentially sourcing it from asteroids.
Yeah, because like I was reading that the current price is like $4,250 a troy ounce, which is like, I don't even know how much a troy ounce is, but it works out to about $150 a gram
Per gram. Yeah.
as of like right now, March 2025. And what's wild is that the Earth's yearly supply of this stuff is only like 3 to 7 tons.
Tiny.
Tiny.
Yeah.
But the demand is huge, like going way up because of all this, stuff in tech and medical innovations, but especially the big push for green hydrogen.
Yeah. And that's what makes it so interesting from a geopolitical perspective as well, because, the majority of iridium comes from just a handful of countries,
Yeah.
South Africa, Russia, Zimbabwe. So you can see how any sort of, bumps in those regions are going to have a major ripple effect on the availability and price of iridium.
Yeah. Okay. So let's talk about that price,
Well,
because looking at like the data is kind of a roller coaster.
yeah.
There was this like huge spike between 2020 and 2024.
Yeah.
It went from like $53 a gram to almost $186 a gram.
It was a big jump.
Like, what happened there?
Yeah. Well, a big part of that was this sort of, booming demand for green hydrogen technologies, specifically PEM electrolyzers, which are a key technology for producing green hydrogen, rely on iridium as a catalyst. And it's because of iridium's unique stability in like the acidic conditions inside these electrolyzers. It's not like the chosen metal for this process at the moment, but it creates a real bottleneck, in scaling up this clean hydrogen technology. And of course, it's not just hydrogen. You've got growing use in OLED screens, which, we all use in our phones and our TVs every day, as well as medical devices and all sorts of other high-tech applications. So all of that really contributed to that big price hike.
So then in 2025, we saw a kind of reversal. The price dropped back down to about $150 a gram.
Mm.
So what happened there? Did the hydrogen hype die down?
I think, it's more than just the hydrogen hype dying down. I think what we're seeing is this sort of like market correction happening. We've got potentially more iridium being recycled from end-of-life products like those PE electrolyzers that we talked about. Even things like catalytic converters, which use iridium, once they reach the end of their life, that iridium can be recovered. And then, of course, there's this sort of anticipation of, alternative catalysts coming online that use less iridium or even no iridium at all. And that can really, dampen those future demand projections. So it's a really interesting picture. 2024 was actually the first year in 7 years that saw a price decrease. So I think that really hints at a potential shift in the market.
Okay, so where do we actually get this stuff? Like on Earth?
Yeah.
I mean, if it's so scarce, where do we even dig it up?
Yeah. So it comes from a few key places in the world. You've got South Africa's Bushveld complex, the Norilsk area in Russia, Canada's Sudbury Basin, and also Zimbabwe.
Mhm.
The U.S. actually has some reserves as well. But the really important thing to remember is that iridium isn't mined directly. It's actually a byproduct of nickel and copper refining. So, you can imagine these huge mining operations. They're pulling out tons and tons of nickel and copper ore. And then at the end of that process, they're left with this sort of, like sludge. They call it anode mud. And that's where the iridium is found in these like tiny, tiny amounts. And then they have to use all these crazy strong chemical solutions like aqua regia, which is like this mix of super potent acids. And then there are all these separation techniques to actually get the iridium out of that mixture. So it's a very complex process.
Which kind of leads to, the whole asteroid mining thing, because we hear about how much of this stuff is potentially out there.
Yeah. Yeah, it's mind-boggling when you think about the scale. So the main targets for asteroid mining would be these M-type asteroids, which are metallic asteroids. And they're basically like these exposed iron nickel cores of, ancient shattered planets. And the thinking is that when those planets were forming, billions of years ago, all the heavy elements like iridium sank to the center. So these asteroids are basically like these cosmic jackpots of, platinum group metals, including iridium. And there are estimates that suggest these asteroids could contain something like 14 parts per million of iridium compared to, less than 1 part per billion in the Earth's crust.
Yeah.
It's a huge difference.
So, like, what's stopping us from going and getting it?
Well, there's a lot of really big challenges, and they fall into a few categories. So technologically speaking, we've got to figure out, how do we even identify the right asteroids? How do we get there? And then how do we develop robots that can actually do the mining autonomously in space? Because, we're not sending people out there to do it. And then we've got to figure out how to process that or on site in space. And then, of course, get it all the way back to Earth safely. And then there's the logistical challenges. The distances are enormous. These missions would take, years and years to complete, and we need to figure out how to maintain reliable communication over those distances. And then, of course, you've got the financial hurdles. The upfront costs are astronomical. Just look at the cost of even those robotic missions that just go out there and bring back a tiny sample of an asteroid. It's a monumental undertaking, and the payoff is uncertain, and it's a long way off.
So, okay, let's say we do manage to pull it off. I mean, what happens then? Do we just see iridium prices plummet?
Yeah, if you suddenly have this massive influx of iridium into the market, you're almost certainly going to see a very substantial drop in price. And, who knows, maybe there would have to be some kind of market management strategy, like maybe a controlled release of the iridium into the market or something. But the other thing to think about is that if iridium were to become much cheaper, it could open up all sorts of new applications that we haven't even thought of yet. But one thing's for sure, it would definitely have a huge impact on the terrestrial mining industry. Those regions that rely on iridium mining would be significantly affected.
So what are the experts saying about, the timeline for this whole thing? Like, are we talking years, decades? When can we expect to see asteroid-sourced iridium actually coming back to Earth?
Well, the consensus among experts seems to be that it's going to be a while before we see asteroid mining being economically viable for, bringing materials back to Earth. The focus initially is probably going to be on in-space resource utilization, so using those resources in space itself rather than bringing them back to Earth. But even then, the timelines vary. Some people are talking about the 2030s, some people are talking about the 2050s or even later. So it really depends on a lot of factors. And, large-scale profitable asteroid mining with, materials coming back to Earth is probably still several decades away at least. And a lot of that hinges on some pretty major technological breakthroughs that haven't happened yet. In fact, one expert I read said that, the idea of precious metal asteroid mining happening in the next 10 years is highly improbable.
So while we're waiting for this space gold rush to happen, what can we do here on Earth, in the meantime to kind of meet our iridium needs?
Well, there are definitely some shorter-term solutions. So one thing is to just increase our recycling efforts from existing technologies. Those PM electrolyzers we talked about. Even things like spark plugs use iridium. So making sure that we're capturing and recycling as much of that iridium as possible is really important. But even more significant is the research that's going on into alternative catalysts for PM electrolyzers. There are some promising materials out there, things like ruthenium dioxide, cobalt, nickel, even iron. And then there's also research into how to improve the efficiency of the current iridium catalyst so that we can just use less of it in the first place. All of these things, could really lessen our reliance on iridium and therefore impact its demand and its price going forward.
It's so crazy to think about, something so rare here on Earth potentially being so abundant out there in space. It's like we're so focused on what's right in front of us that we forget about, this whole other realm of possibilities.
Yeah, it really highlights the difference between our terrestrial limitations and the potential that exists out there in the cosmos. And it brings up, I think, an interesting question for our listeners to consider. Given the long timeline for asteroid mining and all the challenges that we talked about, and then at the same time, these advancements in terrestrial alternatives that are happening right now, what sort of unforeseen discoveries, either here on Earth or out in space, do you think could have the biggest impact on the future of this vital element? It's this fascinating interplay between innovation and resource availability.
It really is.
And it'll be interesting to see how it all unfolds over the next, decade or 2 or 3.
Yeah, absolutely. All right, well, that's our deep dive into iridium. Thanks for joining us.
Thanks for having me.
And we'll see you next time.
See you later.